Welcome to this Misostudy video class, and today, as it is clear from this presentation at your green board, that we are supposed to discuss some very interesting and very useful questions for JEE main pattern exam, and that is chapter is alternating current. Actually, during the discussion of the topics of your regular course, you are supposed to study electromagnetic induction plus AC circuits, alternating voltage and alternating current circuit, because outcome of alternating current is that electromagnetic induction phenomena. Fine. So, I bifurcated these two topics, electromagnetic induction separately and alternating current separately, so that there should not be any confusion, or you should try to feel the importance of this topic. So, now what I will do, as usual, that I am doing one by one, I will keep on explaining the basic idea and concept of each problem, and then we will start the step by step discussion. Detailed solution is also available with your ebook. Fine. So, with this once again welcome to the Misostudy video class. Please to be with me for coming 35-40 minutes for this question answer discussion session. So, students, I am starting your discussion with this very first question. Fine. What is the question? First we will try to understand that. If a direct current means DC, fine. If a direct current of value A ampere, A is basically the magnitude of the direct current, and it is mentioned over here with the help of this diagram. Fine. So, this is your direct current, and this direct current is superimposed on an alternating current. This is your alternating current. Fine. Sinusoidal in nature, and that alternating current is given is equal to I is B sin omega t type of expression, sinusoidal expression. Now, what is the effective value of resulting current in this circuit? Basically, they want to find out if you put together, if you superimpose together, if you combine or mix together DC and AC current, then what is the resultant current in a circuit? So, their question is simple. They want to check the basic idea of your DC current concepts and this AC current concept. So, as you know, here no space is available. So, I will use some space over here, and during that explanation, because of the motion of the camera, it may possible that some portion of the question is not visible to you. Fine. If the space is available, no problem, I will use that space, but as you know, here is no space. So, when the question is slightly out of the camera, I hope you are not going to feel any difficulty, because problem is simply explained to you. Fine. So, let me allow to write down the solution of this problem, and I will try my best to remain close to the this question itself, so that question is also visible to you. Fine. So, first is resulting current after superimposition. Resulting current is I is equal to A plus B sin omega t. Fine. This is a capital B, small b, whatever you want to put. Here just I am providing a symbolic representation or the solution. Fine. So, this is like that, I is equal to A plus B sin omega t. Let us say it is equation number 1, our general equation. You can write it like A plus capital B sin omega t, no problem. Fine. Now, after this IRMS, because you know root mean square value is more important rather than peak value. Fine. So, IRMS is equal to big under root. Fine. Because you have the clarity, or I can say I am explaining these solutions with the assumption that at least you have revised your concepts, your theoretical aspect once in a while. So, at least directly I can mention few things. If few of you are feeling some difficulty with these expressions, my simple suggestion is, please before solving these problems once again revise your basics by watching these regular videos. Okay, fine. So IRMS is equal to this much, that is integral 0 to t, the general expression I am writing, fine, and I hope it is not going to be anyway difficult for you to understand. So 0 to t IAC whole square, fine, into dt upon capital T. Basically this is the expression. IAC is this resultant current. So A plus B sine omega t you have to put under this bracket, and then you have to solve and integrate it, fine. So what I should say, after using values from 1, that is this, from 1, after using values from 1 in 2, and obviously then you have to integrate it, fine. So I am not doing that, I mean just putting the value, squaring them, then integrating them, because mathematics is your one subject. So all these type of basic calculations you not only you can do that, but I know you people love to solve these type of problems, fine, because it's a dual mode of you can say utilization, also you can learn the integration process, fine. So after using values from 1 in 2 and solving, so I hope you will not mind it because there is no space available, so I will have to move over here, fine. IRMS is equal to under root a square plus b square by 2, fine. Now I would like to request you, please move for this discussion. So accordingly it's your answer, fine, a square plus b square by 2 whole to the power 1 by 2, fine. Now as you can see, nothing is difficult in this particular problem. Only difficulty is what? Only difficulty is this formula, or up to some extent, yes, you can say, sir, you are very clever, you skipped out all those calculations. I know that, but if I am putting the value of this a plus b sine omega t whole square, then I am solving like a square plus b square sine square omega t plus twice a b sine omega t and so on, then integrating. So that will take another 5-6 steps, which are anyway not difficult or new for you. That's why I not explained those points, fine, because as such no concept is involved over here, it is merely representation. So now I hope the question with which we started our discussion, you will definitely appreciate the simplicity of this question and the simplest approach of this problem. So let us move for the question number 2, that is, the frequency of oscillation of current in the inductance is how much? As such you can say, let us first try to understand the diagram. There are two inductors connected in series, visible, fine. You can do one thing, you can put a point over here. You can say this point is what? This point is the connecting point of two inductors. So two inductors in series, okay, then two capacitors in parallel, and then entire circuit is arranged in front of you. You can do one thing, I mean you can add up these two using this simple formula for the combination of capacitors, and accordingly over here. Problem is we have to find frequency of oscillation of current in inductance, means because of the cooperation, because of the support, because of the help offered by these two energy storing devices, some current will start flowing in this L and 2L. So you have to find that value. Now I think question is clear to all of you. I should move for the solution. Okay, so once again I am going to hide some portion of your question, because right now options are not important for me. Important is concept. Once I will get the final solution, then I will match the these options given. So now let's try to find the solution. Students, one formula you all are very much aware, that is 1 upon 2 pi under root LC. Fine. Rather than under root LC, I think I should write it in a slightly different fashion. What is that different fashion? This is formula that you are quite aware of that. So what I will do small change over here. I will write it as L equal. Fine. L equal into C equal, because 2 inductors, 2 capacitors, individually why to write down? So write down like this. Ultimately you can find the L equal, that is series combination, C equal, that is the parallel combination. Fine. So that is not a problem for you. So we can find L equal and C equal. Okay, and then put the values over here. So what I will write down? I will write down f is equal to 1 upon 2 pi under root, this is 2 plus 1 3, and this is 2 plus 1 3. So 3L into 3C. Okay, 3L into 3C, 3 3s are 9. Take out, so it's going to be 3. 3 into 2, 6 pi. So what will be your correct answer from here? Correct answer is B, 1 upon 6 pi under root LC. So f is equal to 1 upon 2 pi into 1 upon 3 root LC. So you can write it 3 to the 6 pi like this or in this fashion. Fine. So this question was also a very fundamental question based upon some basic concepts. Fine. So here now we are supposed to move for the another problem of this segment, and till now the questions I picked, I tried my best not to make them anyway complicated. Fine. So that you people can enjoy this discussion. Now once again I am back with the set of questions. So here it is, third question. Resonance occurs in a series LCR circuit when the frequency of applied EMF is 1000 Hertz. Fine. You have a LCR circuit where inductor, capacitor and resistors are connected. Fine. Now if you apply frequency of like 1000 Hertz, fine, then resonance occurs. What is the meaning of resonance? Resonance means VR is not existing, resistance is not important. Fine. You can say VL is equal to XL is equal to XC. Fine. Or 1 upon this omega C is equal to omega into L, and that type of relation. Fine. Then you have to find out that on the basis of this fact, out of these 4 options, which option is correct. Fine. So I don't know any option. What I will do? First I will try to find out which one is the correct option by taking the help of this statement and also reading these options given out, which one is correct, which one is incorrect. So for that we need some sort of explanation. I hope the question is clearly visible to you, but now some portion is going to be hidden. That is, at resonance, fine, at resonance, if I am saying XL is equal to XC, as I mentioned, so it definitely you will say omega L is equal to omega into C. Fine. At resonance XL is equal to XC, it means omega L is equal to 1 upon omega C. Fine, this equation directly we are getting from this relation. Let's say this is 1. This is the condition of resonance in a LCR circuit. Fine. So after this much explanation, condition 1 is if, listen carefully, if XC is greater than XL. If XC is greater than XL, circuit is, I think I should use this space because that way the question is also going to be present. If XC is greater than XL, it means circuit is capacitive in nature. Capacitive in nature. Fine. Now, if XC is less than XL, then what will happen? So, if XC is less than XL, then it means circuit is inductive in nature. Fine. Second situation is, if XC is less than XL, it means circuit is inductive in nature. Okay. Circuit is inductive in nature. Graphically, if you want to show, then you can show graphically as F I, and this is your resonant frequency. Fine. So, A is the correct option. After discussing that much, now let's come over here. When F is equal to 900 Hertz, the circuit behaves as a capacitive circuit. Yes, it behaves as that of capacitive circuit. So, entire explanation with diagram, with graph I provided. The question is in front of you, and this entire thing is going to be the part of your recording. So, at any point of time, you can check it again and again. Fine. And many times few students find it slightly difficult to visualize or memorize certain important results, while if you consider the simple concepts associated, then you will say nothing is difficult in this chapter. Fine. Now, let us move for the question number 4. Let F is equal to 50 Hertz and C is equal to 100 microfarad in an AC circuit having capacitor only. Only capacitor is connected. If the peak value of current in the circuit is 1.57 ampere at any time t is equal to 0, the expression for the instantaneous voltage across the capacitor will be how much? Initially, you have to assume that initial phase difference is nothing, that is 0. Fine. So, then options are given. We do not know which one is the correct option, and we definitely not take a look of the options. Question is in front of me. I will solve it according to the answer. Provided my calculation is correct, you can pick the values, correct values from here. I naught is equal to E naught by B, XC. I think I naught is equal to E naught XC, equation number 1. Fine. After that, what you should do, E naught is equal to I naught into C. What's a great step I explained you. This is something which is very new. This is just arrangement of these terms. Fine. So, E naught is equal to I naught XC. Now, put the values over here. All values are given. So, once you put the values, after putting the values F is equal to I naught C after putting the values in equation 1. Fine. Obviously the expression is going to be changed. Why? Because in this situation E naught is equal to 50 volt. Okay, so E is equal to E naught into C, basic formula. After putting themselves in equation 1, fine, I mean putting the values of these terms in equation 1, you will get E naught is equal to 50 volt is the value of this EMF. Fine. So this way you can say this question is not also a difficult one, basic question, and it just required what exactly your fundamental understanding. Fine. Then one or two good questions from the theory or concept point of view that I would like to ask you. Ask means definitely I will explain you. Now this big question, that's why I am maintaining some distance so that no one must be between you and your question. In the circuit shown, this circuit, if the EMF of source at an instant is 5 volt, this source has at any point of time 5 volt, the potential difference across capacitor at the same instant is 4 volt. So when the you can say instant voltage, applied voltage is 5 volt, then capacitor has voltage this much. Fine, difference across capacitor. The potential difference across resistor at that particular instant is how much? So what exactly you have to solve it? You have to find something specific for Mr. R by taking help of Mr. C, that is capacitor. Fine. And in this particular question, if you try to understand over here, then you will find that there is a specific value associated, fine, across this VR, that is VR is given. Now I can do one thing for this particular question, because while I was picking the question I thought I will not solve this question. Reason being, if you try this question yourself, obviously you will learn few things or you will revise, but there are various type of students. Few of you may say, sir, you only read the question and not provided the answer. So here I am giving you the hint, or you can say small steps over here. Imagine only resistor is present. Is it like that any type of phase difference between voltage and current? No. But only capacitor, phase difference is there, and then if resistor is connected, then there is some phase difference possible. So this way you can say the potential difference across R at that instant will be VR is equal to this much. That is our target that we have to find out. Now if we have to find out that, then what we can say, projection of this let me mention it, projection of phase, on y axis gives instantaneous value, gives instantaneous value. I am writing this much because you can find yourself in a comfortable position, or only thing that I can do is simply mention one line formula, or I can solve it, but I thought it's better to mention the cause also. So projection of phasor diagram, projection of phase on y axis gives instantaneous value of VR and VC. VR means voltage across resistor, VC means voltage across capacitor. Fine. So from here let me allow to erase out this diagram, that is, I think I should use two different colors, 1 and this is 2. Fine. Now, this angle is 90 degree. Okay. This is fine. So, 90 degree, therefore, it is going to be this much is 4 and this much is V. So, find what you can say. You can say V is equal to 9 volt. How? V minus 4 is equal to 5. So, shift minus 4 on right hand side, you will get V is equal to 4 plus 5. That way you can get the value as 9 volt. B is the correct option. Fine. The questions over here are not at all difficult, but yes, they are up to some extent forcing you to learn few things in totality, and by that way you can solve these problems. Fine. Certain questions are of various these basic values also I tried to incorporate, or somewhere I mixed 1 or 2 questions, simple questions together to form a new slightly twisted question. Fine. Here comes your question number 6. As per given circuit, if the value of IRMS is 2.2 ampere, okay, then power factor of resistor and capacitor. Resistor and capacitor means, students, this box. Fine, this entire box. So, question is simple. We have to apply a basic formula over here. And what is that basic formula? IRMS is equal to ERMS upon Z. Or I would like to mention over here, this capital E is nothing but induced electromotive force. So, IRMS is equal to ERMS upon Z. So, from here Z is equal to how much? That is 220, yes, 220 upon next value is 2.2, okay, 2.2, it will give you ohm, and it is what? It is also your resistance, this much ohm. Fine. Now, if this value is given to me, then what is the power factor? Power factor is cos phi. Fine. Power is equal to VRMS IRMS cos of phi. So, power factor is how much it is going to be? It is going to be cos phi is equal to R by Z is equal to 1. 100 upon 100, that will give you 1. So, cos phi is equal to this much. I would like to show you in a diagram also this particular situation. Z R X phi. So, that is a, you can say, a symbolic representation of these values, and here I simply applied the formula. So, not a difficult one, very simple question, okay. And also I am trying to explain all these problems in a very simple and explanatory mode. Why? Because I am also trying to put the diagrams of the questions. During the discussion, I also try my best to use these basic approach so that students should feel comfortable, okay. So, then here comes your next question. An AC circuit, let me allow to remove this box also. Fine. An AC circuit having supply voltage E consists of a resistor of resistance 3 ohm and an inductor of reactance 4 ohm as shown in the figure. The voltage across the inductor at T is equal to this pi upon 2 omega is how much? This sin 37 value is given. If you are unable to recall that, in these type of exams these values are in general provided. Okay. So, I hope the problem is clear to all of you. Let me once more explain it. AC circuit having supply voltage E and it consists of resistors of resistance 3 ohm. So, now we have to find the voltage across this VL, that is target is fine. We have to find the value of voltage across the inductor at time pi upon 2 omega, sorry, pi upon 2 omega. The same formula I will use again, that is I naught is equal to E naught by Z. You can say yes, it is a basic result, V is equal to IR type of formula, class 10th, fine. So, I naught is equal to E naught upon Z, put the values, fine, given over here. So, E naught is how much? 10, this is given. So, it is 10 upon under root 10 upon under root, the value is given as 3 and then next value is 4. So, 3 3s are 9 plus 4 4s are 16. So, 16 plus 9 25, root of 25 is 5. So, I naught is equal to how much? It is going to be 552, 2 ampere. Okay. But you have to find the voltage. So, current will definitely help you to find the voltage, and how you can find it? You can find it that is phi is equal to tan inverse XL by R, that will give you roughly 53 degrees, fine. So, correct answer is D, 4.2 volt is the correct answer. Now, one more thing I think I should mention over here, because then you can say, sir, the solution is of slightly short in nature. Okay, no problem. So, I hope this formula is clear, putting values is fine. It is 2, I mentioned it, then tan phi is equal to XL upon R, I calculated the angle. Do not worry, I will explain remaining portion also. Initially I thought I will suggest you all to please try, but let me explain you. I is equal to 2 sine, because we are trying to write down the equation in the sinusoidal form. So, I is equal to 2 sine omega t minus this value of phi plus minus phi term. So, we have to introduce that term also in terms of phase difference, that is given as pi upon 2 omega. So, when you put the value, you will say tan inverse 4 by 3. Directly putting the values, that is tan inverse 4 by 3, that was 53 we calculated over here just 2 minutes back. So, at t is equal to pi upon 2 omega, as t is equal to pi upon 2 omega, what you can say? You can say that after putting, now trivial calculation part I am skipping, after putting values 2 into 0.6 is equal to 1.2, 2 into 0.6, yes, is equal to, now after this VL is equal to, actually our target is to find out that VL is equal to I into XL, fine. So, put the values over here and you will get 4.8 volt. So, again I will say after putting the values 4.8 volt, that is your answer, fine. So, this question was slightly long in terms of, you can say, integration and calculation, calculation. So, therefore, slightly long question, but as such not a very tricky question, anyway not a tricky question, fine. Now students, I think we should go for the next problem, that is question number 8. This problem, because one of the question I explained you which I was supposed not to explain you. So what I'll do, I'll explain the problem, then I would like to request all of you try this question yourself, because if at any point of time you are finding it difficult, the solution is provided in your ebook. So when I will explain the problem, after that what is suggested to you, stop your video, think yourself, solve it, and then you can take the look of the solution. Obviously I will provide some sort of hint over here. Listen, the given figure represents phasor diagram of a series LCR circuit connected to an AC. First hand impression is LCR means it is given capacitor, resistor and inductor, all three are associated. Fine. Now at the instant t when source voltage is given by V is equal to V naught cos omega t prime, the current in the circuit is how much? So obviously the current is going to be sinusoidal in the form. So out of these four options, obviously someone is the correct option. How you will find out that? What is your approach? I think you will follow that basic approach which I explained you during the discussion of this topic. But quickly I think I should mention this, and that is phase difference between, now we want to find the phase difference between all these three components. So that way I am providing you a very short explanation, that is phase difference between EMF and current, between EMF, electromotive force, and current. Phase difference between EMF and current is tan inverse 3 minus 2 upon root 3. Values are given over here, every value is given. Fine, I am not doing anything great, I am simply putting the values in the formula which are given in this diagram. So tan inverse 3 minus 2 by root 3, and it will give you how much? It will give you 1 by root 3. 1 by root 3 is pi by 6. So if directly I can mention, then I can say phi is equal to pi by 6. I hope you will understand this. 3 minus 2 is equal to 1 by root 3. Tan inverse 1 by root 3 means tan 30 degree. So rather than writing 30 degree, I am writing pi by 6. Okay. So if phi is equal to pi by 6, then you can easily check out which one is the correct option. So pi by 6, therefore C is not applicable, D is not applicable, minus it should be fine. So B is the correct option. So the question is simple, where if this diagram is not given, then yes, up to some extent few of you may have to struggle a bit. Otherwise, if the diagram is given, then things are not so difficult over here to visualize and to understand. Fine. Now let's move for the another good question, that is the average and effective value for the wave shape shown in the figure. Let me mention few things over here. Purely formula base. Fine. As such, no, not a difficult thing involved over here. Purely formula base means just few results and you will get the values. What are those results? Obviously, I should suggest that for this question also, you should try yourself, because just a sort of revision I want to ensure. That's why I am putting these type of questions. But I don't want to give chance to any student who can say the solution has been not provided. Fine. So just as a hint, I am providing you the solution. V average is equal to, now once again some sort of integration differentiation is required. So V average is equal to 0 to pi by 2. Why the values are 0 to pi by 2? Easily you can understand from this value that I am putting the value of the integration as 0 to pi by 2, that is V naught sine omega t dt. Fine. And below it is again going to be the total time of this expression, that is t by 2, t by 2, t by 2. So it is t, so half of that, that is t by 2. Now integration is not a problem. V naught sine omega t dt, V naught put out, sine omega t dt integrate accordingly, and then put the values. Obviously you will get the terms in the term of the cos term. Fine. So once you get the values in the form of this cos term, then finally you can say that VRMS is equal to 2 by pi Vm and Vm by root 2. So average value is VRMS is 2 upon pi, it is mentioned over here, Vm is this peak value, and effective value, integration of this term I am leaving, effective value is Vm by root 2. Fine. So now you can say this question was not a difficult one, and if I am providing this question to the medical entrance exam students, then obviously few of them may feel slightly difficult over here. Otherwise this question is not anyway difficult for at least you people who are studying mathematics as a subject. Fine. So you can say yes, this chapter electromagnetic induction and your alternating current is very simple one chapter, very useful, very scoring and very important. A series circuit has a resistance of 60 ohm are given and an impedance of 135 ohm Z. When the total potential difference is 120 volt, the power consumed in the circuit is how much? Now I will not suggest anything, I will not say anything. What I will do? I will simply say that P is equal to VRMS IRMS cos of phi. Nothing is difficult, nothing is new for you. Simply put the values over here. I think I should mention it also. Putting the values 47.4 watt is power. I hope you realized one thing. Deliberately I am skipping steps. Deliberately I am providing you just hint. Reason is simple. If I will provide you entire solution over here, you will just watch it and then forget it. If I will deliberately put some steps out, will not explain each and everything, then that will force you to revise. Solutions are available in your ebook, not a problem. But my intention is simple. Don't take the look of the solutions initially. Initially take the look of this question and whatever the hint I am providing. After that, if you are finding it difficult, then don't take the solutions. Once again I am saying, go back to the basics, revise them. Then take a look of the solutions where you are committing mistake. This is the approach, because if I will provide you the solution of 1000 problems and just by watching them you are not going to gain anything. Fine, unless and until you are not trying from your side. So that's why deliberately I am skipping. I am just giving you some hints, some formulas, some calculations, not everything. I hope you will appreciate this effort. Fine. Otherwise it's your choice. If you will say that please provide step by step solution over here, I don't have any problem, but solutions are already with you. Okay, so with this I would like to say thanks to all of you for watching this video. and keep revising. Take care of yourself.